Hey, good afternoon. Jim Warren with TXAPA. Glad you are here today. Welcome to our optimization series. This session will be on optimizing mix design, and we're glad to have you here. Let's go ahead and get started. We got a really busy show today, and we got to go through a little bit of admin stuff before we get started, and we can get down to the details. So let's click through here. This program is being recorded, and you'll get a link later on. Hopefully, we can get the PowerPoint deck shared as well. We'll be using the Go to Webcam feature, Go to Webinar Webcam feature only for this, and I'll show you how to adjust that if you're new to our series. And we are taking questions at any time, and we really would like you to weigh in on this and get as much out of this as you possibly can. We got a great program today, and I'm excited about it, and I want to get you in there. So if your screen looks like this right now and you just see a little bitty box, if you double click on that screen, that should take you full size. If that doesn't work, right down in the bottom right hand side of the corner, there's a little double arrow. If you click on that, that should take it full size to maximize the webcam screen on your computer. Any questions at any time, we'd love to have you type them in. Hey, if you want to give it a shot, just type in what city you're from right now and hit send, and see if it works for you. But go ahead and type your questions in anytime. We'd be glad to have you weigh in, because we got a great staff here, and great folks are going to participate today, and we're really looking forward to it. So this is today's lineup. Again, we are excited about it. Here's me again. I'm trying to play around with some of this stuff. I'm going to do the safety share as we get started. This is our optimization series. Just a little bit of background on this. About a month ago, Chuck and I started doing some one-on-ones with our members, and as an offshoot of that, we decided to produce some materials that would be designated more towards the people that are in the field, both at the plant and out the roadway, including mix design. So we've got today's topic is mix design. The 28th, which is next Tuesday, will be on plant production. I've got TJ Young on that. Great. TJ is an awesome guy in plants. And then on August 4, we've got roadway operations. I got Todd Mansell from Caterpillar. A lot of you guys know Todd, and he'll be around there for that sample. So I want to get into our safety share real quick before we get started. Let me get rid of that. There we go. That's what it ought to look like. Just talk about sampling binders. You know, there's a big push right now to make sure we are getting samples of both emulsions and binders as part of the department's program to evaluate and make sure we're putting the right stuff on the roadway. And we are actually working on some little video shorts to kind of show different types of sampling, whether it's from a tank or a transport, a distributor, etc., or even inline samplers. And we'll be getting that out probably within the next month or so. But I just wanted to cover that just very briefly. I was at Industrial's plant there in Buda, which is probably a mile from, as the crow flies, from our office. But they've got they've got a big poster that's posted right above where the tank is, and it talks about loading and unloading liquid asphalt safely. And these are things that if we're going to be taking liquid asphalt samples, we got to make sure we're doing it right. And one of the key things is wearing proper PPE. And this gentleman is the guy that was taking the samples at the plant in Buda, and he did a great job for us. And that's what his stuff was. Every time we showed up, that's what he was wearing. So we appreciate that. So again, oops, hang on a second. I'm too quick on the trigger here. So, proper PPE goes to, long sleeve shirts, long gloves cover the wrists, no bare skin, face shields, or at least glasses. A lot of people are wearing masks now because of COVID. Long pants, good solid boots. So if there is a possibility of if you look at the guy that's on the screen, if any sort of spray hit that guy, it would not hit his skin. It would hit something other than that. And in many cases, he's got 2 to 3 layers on that's protecting him. So we just want to get this out there. We want to make sure that everybody understands. Oh, we got somebody from Weatherford, Texas. Thanks, Sarah. So you guys are listening to me. I think that's awesome. So we appreciate that. but we want to do that. We want to make sure everyone is doing things safely as we move forward. So again, kudos to Industrial and Austin Materials for having this at their plants. I've been impressed going out to job sites. I've been out on a couple job sites in the last couple of weeks, and everybody's had their stuff on. So it's good news. It's great to see. I'm excited about it, and we just got to make sure we're doing the right thing as we move forward with this whole program. So, oh man, I'm out of breath already. So we're talking about optimizing mix designs today. I want to bring in our panel. That should be up on your screen right now. Top left, that's Chuck Fuller. Chuck is a consultant, works for TXAPA, and everybody knows Chuck, I believe. Jimmy Whitehead works for Austin Materials. Great guy. He actually worked for TXAPA at one point in time way back. And Ryan Barborak, everybody should know Ryan. He's taking care of us from the asphalt side. Oh, we got a lot more people kicking in. Dallas, Barrett, Texas, Dallas, another Dallas. Good job, guys, weighing in here. So this will be our panel today. We're going to start out with Ryan. And if you guys don't let me switch over to a different deck and get that up and running. Ryan, you want to go ahead and say good morning or afternoon to everybody?
Good afternoon, everyone. Glad that you could participate in this webinar. I think it's going to be very useful for everybody on the call. We try to make this as practical as we possibly could, but we also try to make sure that everybody understands why we made the changes that we did. And so Jim is about to pull up a presentation that is going to, so what I'm going to do is I'm going to discuss basically some basics. I'd like for everybody, just want to make sure everybody understands the fundamentals of what we're calling the Power 45 curve. You'll see that in the tab all the way to the right on your gradation chart in your mix design templates. And so I think sometimes we need to pay more attention to this graph because this graph actually makes a lot of sense. And so what I was going to do is kind of very quickly but fundamentally walk through what this is, if you will. And so basically when we say it's the Power 45 curve, that's what we usually denote it as. Basically what you're doing is you're taking the sieves, you're putting them on the x-axis, okay? And you're taking those sieve sizes, you're converting them to millimeters, and you're raising those millimeters to the 0.45, okay? On the y-axis, you have your percent passing. And what this allows you to do is that it allows you to start putting in your master gradation limits, okay? And then it's also going to plot your master gradation. It also allows you to basically draw what we call the maximum density line. And we're going to talk about that in a few minutes. What you see on the screen there is an example of the Power 45 curve. You see on there, you see the gradation limits, if you will. You do see the master gradation. And then if you look on the right-hand side of the screen, you'll see the gradation limits. This is actually the gradation limits for item 344. We will get into the discussion about how we change those gradation limits as we talk about 3077. Next slide, Jim. I wanted to point out too, when you look at the Power 45 curve, you'll also see what we call the reference zone. It was formerly known as the restricted zone. It's basically a zone there that, over time, through research and through, the last 20 years that we've been doing Superpave, the idea was to not design through it because it could lead to sandy mixtures. It could lead to VMA issues, if you will. It could lead into tender mixtures. And so what you'll see on the Power 45 curve is we also have what we call the reference zone. It's also in a table in our specification. And so basically it starts at the number 8 sieve and it goes down to the number 50 sieve. Next slide. So the maximum density line. Why is the maximum density line important? Well, the maximum density line is basically telling us how much room we have for asphalt, okay? The way that we define the maximum density line is we have what we call the nominal maximum aggregate size, This size is the sieve that is one sieve size larger than the first sieve that retains more than 10% of the total aggregate. And then we also have a terminology that we use that's called the maximum aggregate size. This is one sieve size larger than the nominal maximum aggregate size. So when you draw the maximum density line, again, the maximum density line is saying exactly that. It's the maximum density that you can achieve. When you draw that line, you draw it from the point of the origin up through the maximum density line. And so that illustration right there that you see on the screen is showing you how we define and how we draw the maximum density line, how that actually, how we derive that, if you will.
So
And
on the oops, let me go back there. Oops. So on the type C, the nominal max aggregate size is a 1/2 inch, right?
That's correct.
Yeah, good deal. Okay.
That's correct. That's right. And so you can see the color codes there.
All right.
That's correct.
Good deal.
Typically, more often than not. So if we go to the next slide. So as we said, you've got the maximum density line, right? And so anytime that you deviate off that maximum density line, essentially what you're doing is you're creating room for asphalt, okay? And so
oops.
See on the top graph there, you'll see where basically we have the arrows drawn. So anytime you move down and to the right on the maximum density line with your master gradation is kind of that S shape, if you will, that S-shaped curve.
Mm-hmm.
Anytime you move down and to the right, that means that your mix is getting coarser. Anytime you move up and to the left, that means that your mix is getting finer. And so what we try to do in this particular example is kind of illustrate, these are two different master gradations. You can see on the bottom, you have design 1 and design 2. You can see the room that you're creating for asphalt, okay? So anytime you deviate off that master gradation line, you're creating room for asphalt. So what that's suggesting is that design number 1 would have more asphalt in it than design number 2, which also means that it would have a higher VMA as well. So it's just kind of giving you a background, kind of an idea of what we're trying to do, because this is going to help answer some of the questions that I know we saw in the email from TXAPA. So again, when you move off that maximum density line, you create room for asphalt. You have higher asphalt contents given a targeted density.
Okay? And you got to make some room.
Got to make some room. So changes to the master gradation. So I think as everybody's becoming aware, we did make some changes to the master gradation limits. When you look at 344 and you look at special specification 3077, you will see that the master gradation limits are different, okay? So to explain why we made that change, so one of the reasons why we made the change is that we recognized that moving away from the maximum density line would create more asphalt, okay? So by changing the master gradation, it should result in having additional asphalt in the mixture. There was some concern. So the way that, so we wanted to move away from the maximum density line, but you had one of two options, okay? So you can either go finer, so you can go above that maximum density line, or you can actually go coarser or below that maximum density line. So you have two choices in order to create room for asphalt. Well, we had some concerns with some of the districts that when we went above the reference zone, it tended to produce mixtures that had some challenges with friction, okay? And so the concern was friction and designing above the reference zone. So the choice that we made, the decision that we made was to go below the reference zone. Now, in addition to that, we kind of also had some other options besides just designing below the reference zone. So one way that we could have wrote the note was to just that, to design below the reference zone. But we felt like if you design below the reference zone, now we're kind of limiting 4 sieve sizes, which would be the number 8, 16, 30, and 50.
Mm-hmm.
But so instead, what we did is we said, okay, well, let's focus on one particular sieve size. Let's focus on the number 8 sieve size. So that way we impact only 1 sieve instead of 4, if you will. And so what does the new spec say that's different than the old spec? Number 1, it says do not design above the reference zone. And number 2, you will see there's a limitation on the number 8 sieve, okay? So when we were in the process of doing all this back about a couple of years ago or so, we looked at several mixed designs, and these were approved mixed designs, so they were the JMF1, and probably 95% of them were already meeting this requirement. So basically, you had designs that were already meeting this requirement from a JMF1 perspective, and so the idea was is that we didn't see any concerns there, because that is what what the data was suggesting to us. In addition to that, we also reduced the wrap content by 5%. So that's one difference that you'll see from Superpave special specification 3077 versus item 344. The whole goal here was to increase asphalt content, okay? But also by increasing the asphalt content, when you pick the number 8 sieve and you start to move that number 8 sieve down, you also start to see that you start to produce mixtures that have stone on stone. So, they always have that expression of can't have your cake and eat it too. Well, what data is suggesting is that when you do start to design stone on stone contact and you do increase the asphalt content, it doesn't tend to affect your rut resistance. So in other words, you're able to get increased asphalt contents and at or maybe slightly below similar rut resistance. And so those were the main reasons why we picked the number 8 sieve to make the adjustment.
Hey, I got a question already that came in. Maybe I think I need to pull back up to maybe here or so. Let's see. Can we discuss the maximum density line more? Question mark. If you look at the first maximum density line, it is 1 sieve below nominal, and then the example used with 2 designs, it is at the nominal. I'm not sure if that's the right. Is that the right? Yeah, I think that might be the right slide. Did you understand that? Can anybody weigh in on that?
Yeah, Jim, I do. And so, as we said, so Jim, you asked me the question earlier about that. So first off, we need to make sure, I know for some period of time, which our template should be correct now, when we drew the maximum density line, there was a period of time where it didn't line up like it was supposed to.
Okay.
But in addition to that, what it could be is that, we do have on this slide here, what's highlighted in red, what's highlighted in blue, right? Those are typical maximum aggregate sizes and nominal maximum aggregate sizes. But remember, what we're calling our nominal maximum aggregate size is that 1 sieve size larger than the first sieve that retains more than 10% of the total aggregate, right? So
that could vary based on the design.
That could vary based on the design and based on your materials and how you put those materials together.
Gotcha. Okay, very good. Hopefully that answered the question. All right, moving on.
And so these are the new gradation bands, if you will. When you compare item 334 to special specification 3077, this is showing you a Superpave B mix. So because we said do not design above the reference zone, you can see we necked down the gradation bands at the number 8 sieve, and then the corresponding sieves that correspond to the reference zone. So that's why you see that little uptick on just above the maximum density line.
Gotcha.
So next slide, Superpave C.
There you go.
So again, on Superpave C, we said do not design above the reference zone. So when you look at the number 16, 30, and 50, that's reflected. And then what we also did is on the number 8 sieve, we further reduced the number 8 sieve to 37. So your gradation limits on a Superpave C mix are 28 to 37.
Okay, good deal.
And then last one, if you go up one, Jim,
not bad. I'm sorry.
This is our Superpave D mixtures. Again, in the specification it says do not design above the reference zone, and we also neg down the number 8 sieve. So your master gradation limits on that number 8, where your Superpave D mixtures are 32 to 40.
All right, good deal. Hey, any questions anytime, go ahead and put them in the box and send them to me. Appreciate it. All right, ready to move on there?
Yes, Jim, so this is an example of what I think may be going on, and I just wanted to share this with those on the call and with our industry, because this is something that we went through, I guess, if you will, whenever we were looking at a design. And so what you see on the screen is you see the master gradation in orange, you see the maximum density line, you see the lab mix details. It's Superpave C7622, 20% wrap, 35 gyrations, and an AC content of 5.5%. So basically what you're seeing is the master gradation of the mix that was produced in the laboratory. So if you click to the next slide,
There we go.
this is actually the gradation. So what you see in blue is the plant gradation. Okay, so this is as we're trial batching the material. You can see what the lab gradation is there in the orange, and then what you produced in the blue. Okay, and so if you look, our optimum asphalt content was reduced from 5.5% down to 4.6% AC.
That's a lot.
That's significant, right? And so we don't know exactly what's going on here. We think that I have two explanations, or maybe third or fourth, but one explanation of this could be that the material is breaking down as it goes through the plant. Another explanation could be that maybe maybe the bins aren't calibrated, as well as they should be. I'm just trying to come up with solutions, I guess, if you will, that could be causing this. But basically what this data is suggesting is that the material is fining up as it goes through the plant, okay? And so if you go to the next slide, so what did we do? We worked with the contractor. We said, okay, we know that this material is breaking down. And one thing I need to also say about the previous slide is that if you came up with a 5.5% asphalt content and your actual gradation is the blue line, your lab molded density is going to be 98%, could even be higher, okay? And so what we decided to do is we worked with the contractor and said, okay, let's account for that aggregate breakdown, okay? Or that shift in terms of that material getting finer as it goes to the plant. So what you see in the purple line there is where we went in and said, okay, we're going to make the design even coarser. So we're going to adjust our bin percentages to make that mix coarser so that when it goes through the plant, we can account for that material breaking down or that material fining up. And so if you go to the last slide.
Okay, then I'll do that. Then I got a question that came in. Go ahead.
Okay. And so this is basically the light blue line, if you will, is the gradation that was produced after we made the adjustments to the original design. So you can see that we've more closely matched the orange line, and you can see what our optimum asphalt content was, which was 5.1%.
All right, here's a question for you, Ryan. Now that we are several months into the 3077 spec, what is an average increase in the asphalt content percentage across C and D mixes versus where they were at with 3044? Excuse me, easy for me to say.
So, Jim, I would say somewhere right around 0.5%. 0.5%, reason being is because there's about a 2.5% increase from reduction in the wrap content, down from 20 to 15%. So if you're assuming a 5% in your design, typically, 20% would be 1% AC. So that since we've reduced that to 15%, that means that 0.75% AC is coming from the wrap. That additional 2.5 if you will, is additional virgin asphalt that was added to the design. And then by making these gradation changes, what I've seen is about another 2.5, maybe 0.3. And I think Jimmy's going to talk more about that when he starts to talk. So
okay, good deal.
Somewhere right around 0.5 is what we're anticipating. But again, about half of that is coming from reducing the recycle binder ratio.
And I got one more question. Let's see. I think the problem is the template allows for the mix to be in the master grading during trial batch and does not grade against design, resulting in a 1A telling their supervisor the trial batch passed.
And so the way that the new template, and this is, I need feedback, right, to make sure that, our templates are working, properly. And occasionally we do get feedback from industry. But the intent of the spec is that any JMF changes need to be within the master gradation. We still allow the operational tolerances that are in our table in the specification. But when a JMF is submitted and approved, and that includes JMF changes, the JMF needs to be within the master gradation limits.
Gotcha. One more quick question came in. Are the gradations dry or washed?
That's a wash gradation
okay.
on the mix design.
All
And
right.
so that's where aggregate correction factors come into play, right? That's why it's so important that we're utilizing aggregate correction factors, because what you're trying to do is you're trying to take a burn sample and you're basically trying to convert that over to a wash gradation. So in your mix design, your JMF1, that's going to be a wash gradation. But it's also important that we're doing our correction factors and making sure that those correction factors are accurate. So that way we're getting accurate values, both for gradation and AC.
Okay.
Good questions. And so anyway, this is kind of a summary of that. And so if you go next, and I wasn't going to spend a lot of time on this, guys, because I kind of want to get into the meat of the presentation. I already see we're about 25 minutes in. So I just wanted to introduce the Tx2MixSolver template, but I also wanted to make a point. So this is a template that you can download off the TxDOT website, or actually I should say off the internet. I believe it's actually on the TxDOT website, but the point being is that this was intended to be used as a tool, if you will. And so we feel like we did a pretty good job of including the instructions, if you will, of how to use this template. If you go to the next slide, Jim. And actually, I'm just going to skip this one as well. So the idea is that you input all your gradations, and that includes all the materials that you're planning on using. And then you hit this optimize button, if you will, and it will give you a gradation. And if you go to the next slide, Jim, you can see based off of on here, and this is why, again, I think it's very important that we started our conversation with this. You can see the master gradation. So this is kind of the graph that we're trying to create with those bin percentages, okay? So what we're shooting for is very low on the number 8 sieve. It's close to the maximum density line at the top of the curve, if you will. And so my point is that when you use this template, it's going to produce probably the most coarsest mix that you can get with the materials that you're inputting into this program, okay? And so what I'm saying is that, you know, this is going to give you a ballpark number of where you need to be, but you need to be making adjustments as well. And so, and keeping in mind that this is going to be the coarsest mix that with your materials that is going to be produced. So,
Okay. I got
we,
one piece of feedback that came in here. Unfortunately, by the time the JMF is made, it is too late, and where you are finding these issues. I've been doing consulting for the last 6 months on this, and every time I find this to be the case. So apparently the statement is by the time the JMF is made, it's already too late. So what's the solution there?
So by the time the JMF is made, it's already. So I think so for me, what the solution is so me personally speaking, right? My solution would be go out there, measure the gradations of your materials, and adjust your bin percentages in order to match the master gradation that you came up with in the lab, right? That's one of the keys, I think, to making this all happen, is that not only are you trying to match the gradation that you did all the testing on in the lab, but then you're also trying to continuously match that gradation, consistently match that gradation, because if you can consistently match that gradation, you should get very, very similar lab molded densities.
Okay, good deal. All right, good deal. Was that the end of that deck, I think? Nope, there was a couple more. Hang on a second. There we go.
And so, yes, and so this is kind of just showing you an example of what that template does. So there's a standard item 344 mix. That's when you use the template showing you the mass. So the the blue is the item 344 mix, basically. And so when you put those same materials in this solver, it gives you that red line there at the bottom. So and of course, because we restricted the number 8 sieve, that was the whole intent, is to try to get our designers in the ballpark.
Gotcha.
That makes sense.
Gotcha. Okay, good.
And so I know, Jim, whenever you sent out the agenda, we had kind of, we're at some point we're going to open the floor to discussion, but
right.
But understanding why the specification gradation limits were changed. So we showed the slide, right?
Mm-hmm.
We wanted more asphalt.
Yep.
We wanted stone on stone, so that way we knew that, that way you get better rut resistant. And I was going to also answer number 2. I was going to turn it over to Jimmy, but what does this have to do with the balanced mix design? I know that that question's come up, and I know that we have had a lot of initiatives around the state. We're putting down test sections, now to try to evaluate the balanced mix design. Where this comes into play is that one of the key factors that we're looking at in terms of getting a balanced mix design is gradation. We are looking at gradation. How can you adjust gradations to achieve a balanced mix design? And what we're finding is that it's not in every case, but in many cases, the way that you achieve a balanced mix design is when you look at the master gradations, you will see that you start to reduce that number 8 sieve. And the reason why you're reducing that number 8 sieve is because you're opening up the gradation, if you will, to allow more asphalt into the mixture. And at the same time, you're giving more of a stone-on-stone contact to compensate for the increased asphalt content. So what does this have to do with the changes? I think in the future, when we start to look more at the balanced mix design, this may be what you're going to find as a designer is that you may need to start even coarsening up our mixtures even more in order to get them to meet the balanced mix design requirements. So,
well, I mean, you got to get started. You got to get started with this. I think this is a good starting point, working with this, and as we get into BMD or balanced mix design, it'll be another evolution, from this whole thing. But I think where you guys are at right now is good stuff. So I think what we're going to do, are we going to switch over now? Is that what we're going to do? Is Jimmy's got some information he wanted to share. So Jimmy, if you can go ahead and pull that up, we'll get that up and running, and then I'll flip it over to you, and we'll get going. So hey, I appreciate everybody. I appreciate all the comments and the questions so far. And let's break time is over. Back at it. Here we go. All right, Jimmy, all yours.
All right. Howdy, Texas. I want to kind of let how do we get there? Ryan gives you the technical side, all the data, and us as contractors. How are we going to take what we have and get there? Well, there's going to be multiple ways. I figured the best way to show you, let's just go to their template, and this is an actual working design. When we started looking at this, I want to say, Brian, like 2 years ago, we started looking at this. We were analyzing mix designs, and we brought this up with our level 2 committee and started going through. And we had some designs, So about a year ago, we started playing with them, and we started right here. I highlighted the number 8 in yellow. This design originally started at a 38, which y'all saw that the new spec, you got to be below 37. So we started with the gradation. We wanted to see what happens just by changing the gradation. This was a 50 gyration, type C Superpave Sac A. This is a river gravel mix with some limestone mixes that are hard limestone, I put D rock since it's not a true grade 4. This is actually a D rock, so it's kind of a DF. The F is pretty much a really fine F. You got a wash man sand, and then you got a field sand. And when we first started off on this design, we were doing 50 gyrations. Optimum AC started off at a 4.5, and we would struggle to get a 92 in place density. So, going off of some of this whole thing is, we're like, all right, well, let's start pushing it down. Well, the first change automatically, if all mix designs, which should be done at 50 gyration. But as soon as those designs are done, you get those preliminary numbers, and you got your bend percentages, and like Ryan was talking about, you got to coarsen your mixes up just a little bit when you run them through the plant. You need to request to switch to 35 gyrations. You design at 50, control at 35, because 50 gyrations, Superpave press, we have 3 of them. We have a Troxler, we got the Big Pine, and we got the little baby pine or the Bravo. The Superpave presses do not like fine mixtures. I mean, they fine mixtures, they're going to show over compaction, and you're going to fight with high density all the time at 50 gyrations. Switch to 35. You switch to 35, it's the exact same mix. Your density comes down. But when that density comes down, that allows you to put a little bit more AC in it, because we know once you start coursing up a mix, If you don't want segregation, you got to have the proper AC. So just by switching, you're going from 50 to 35, you're going to pick up a few tenths of AC. And then what we did is we started stair-stepping it down. We stair-stepped it down from 38 down to 36. And when we stair-stepped it down to 36, we saw our optimum AC come up. We double-checked Hamburgs. Hamburgs, they did get a little bit higher because we got more AC in there. Mm-hmm. Well, always like, well, this still ain't enough. We're struggling to hit VMA even with 35 gyration. So we came in here and we pulled some more field sand out. We took one out of the field sand, and I want to say we took our wash sand down and came in here, put some into the grade 4, and then we put some into the D rock, and we coarsened it up more. So we went from that 38 down to 33, and now we got this mix all the way down to around 31, 32 on the number 8 now. So let me go in here. So as you can see, we pushed it down even more. When we did that, this is like I said, this is a river gravel mix. So you got super low absorptive aggregates right here on these two. You want to keep your C down. You don't want a lot of big rock. And that's where a lot of people make a mistake when they're trying to coarsen their mix up. They put too much back into the top end. Well, you want to try to put a little amount as possible on that top end because that'll save you from segregation issues in the field.
That's a good point, Joey. Thanks for saying that.
So we started taking it out of here, putting it back into the grade 4 and into the D rock. And if you notice, this is a big key. You see how many bins this is. You know, this is a 6 bin plus wrap, so it's a 7 bin mix. The old days of 4 bin mixes are gone. You know, with the new specs and the direction we're going in, I mean, you're going to have to start 5, 6, 7 bin mixes to be able to control a gradation sensitive mix. So, you know, getting these split out, pushing this down, we took an original design that was 4.5 AC at 50 gyrations. We dropped it to 35 gyrations, picked up a couple tenths of AC, pushed the gradation down. We got a Type C SAC A 76 sub 70, and we got a 5.0 AC in this mix. And our Hamburg, we double checked the Hamburgs each time. We went from a stiff mix. You know, I think it originally rutted it at 4. We jumped that 4 up to a 5.5, and then got it all the way up to a 5.0, and we're pushing 6.7. So say a 7 millimeter rut is what we're pushing with the 70 minus 22, just by pushing this gradation down. Everything kind of locked in, and we started doing this with other mix designs. We did the same thing with our Ds. We did it with our Bs, and what we're starting to see is our Hamburgs are still passing with the addition of oil, and we're seeing that the majority of the rutting is from 0 to about 6,000 passes, and then it flatlines, which that's what you want to see in a Hamburg. That means you're locking in the aggregate, and it's locking in, and it's not going anywhere. So you're stopping your rutting. And this goes, all these changes kind of stem back to when was I at TXAPA, Chuck? 2015, I believe. 2015, us as an industry with TxDOT is like, what can we do to get 1 or 2 more years of pavement life? Well, back in 2015, the big slogan was, we need to raise the bar. We got to raise the bar. And we, you know, us as contractors bought into raising the bar. Well, we knew going to Superpave was one way to raise the bar. You know, it tightened up the spec, it tightened everything up. And then from raising that bar, we've been making minor changes to that to make these mixes more durable, make them last longer, and kind of keep continuing on to make sure we get that 1 to 2 years of extra lifespan. So, you know, everybody's aggregates, like Ryan said, most mix designs were already close. So if you take your old mix designs and And don't worry about these other sieves. By just adjusting your number 8 sieve, which are, typically is going to be your F3, your F man sand, your field sands, and just pushing those up and trying to control this one will automatically control your top, and then it will automatically control your bottom. Now, when you have this type of mix that has a little bit coarser structure, you start getting repeatability with that Superpave press. That Superpave press does not like fine mixes. So when you start getting the rock in there and you start molding, you start getting consistency. And when you get that consistency, that's how you're going to optimize your bonus money. Superpave mixes let you go up to a 7.5% bonus. So getting that consistency is big, because it also, now you can't deviate by more than 1.3% or it's remove and replace. So taking your mixes, pushing that to below that 37 on the type C or below 40, you have to still find your sweet spot. You're going to have a good QC department. You got to do your research. Each mix is going to be just a little bit different than the other mix. But once you do this testing and pull this data in and make a major change in a day where you can see what's below this or what's right above it, as soon as you get into that really good number, on that number 8, and you lock it in, you're going to maximize your densities and you're not going to see any fluctuation. And a lot of this also starts with something that we used to do back in the old ramming days, and we still do it now. We run quick samples. Our QC is there when that plant starts up. They pull a sample off the drag and they take it to the lab, immediately run a set of molds and a gradation AC content. We know that mold, since it didn't cure, is going to mold a little bit higher than a 2-hour cure. So, once you log enough of those samples, you kind of know what that deviation is. But then you got a quick gradation and a quick AC, and you can kind of see and know that, hey, our gradation looks good for the day. And then once you lock it in, you're going to see some pretty consistent results the rest of the day.
Good deal.
Jimmy, I want to hone in a little bit on the fact that you have 6 bins, and the fact that when you have these bins like this, those bins have to be calibrated for the percentages of aggregate going through them. And that's one of the big things that I see, is that we change these bins, we change these percentages, but we're back and look at our calibration for the bins. And then also, I want you to talk a little bit about control charts, because when you start talking about 23% man sand and your moisture in that man sand goes up, you know that you're going to have struggle. You're going to be struggling some, right? So talk about your control charts that you have out there at the plant, where you do specific gravities, moistures, and gradations, and then chart that material, especially if you're buying material from the outside, because gradation, these designs that you're talking about and this new Superpave spec, it is so sensitive to gradation changes. So talk about a little bit about that.
So we have in-house Excel sheets, and we actually just put them on the Google Drive to where any technician now can log in. And I mean, we run daily moistures. We're running daily moistures. We run weekly stockpile samples for gradation, and all this is logged. And those moistures are logged, and you can you can go in and look at a 7, 10, you can go do a 6-month average to see what your moistures are coming in, and we watch these moistures and tie those moistures back, because on the same sheet, you have your stockpile gradations, you have your moistures, you have your hot mix samples themselves with densities, gradations, everything. And when you start going and tying these numbers in, they all reflect to each other. You get a heavy rain, we will not crank up a plant if our stockpile moistures are above 10%. If you're cranking up and you have stockpiles moistures above 10%, you're asking for trouble. Your sands are not going to feed correctly. You're going to have a really, really weird mix for that day. It's going to have a super high AC. You're going to have a high in-place density or high lab density, and your gradations are going to be out of whack from the sand not feeding correctly. So a 10% is kind of that's the number we use. Is that the right number? Every aggregate's different. So 10% is our number. But by logging these and tracking them, and these are all filtered, so you can filter this stuff to see what you want to see, and you start comparing it. They all directly reflect the next the same system on the calibration of the plant, the same on what you're feeding and how it's going to feed for that day. So you kind of start getting into a pattern with your technicians and your plant managers of when this happens, we automatically know, hey, today we're going to have to add a little bit more sand because, our moistures are 8%. Let's bump that sand up, 2%. Let's take it out of here just for our first sample. If it doesn't work, we'll make that change back. So having a good, strong QC department that works with the plant is going to be pretty vital in this case.
All right, then, so let me jump in here. We got a couple good key takeaways here. Key sieve number 8, right? We're checking moistures, we're control charting, and we're trying to minimize the top end. And I had one comment, agree 100%, that people see that Superpave C, they use 30% C rock as a way to achieve stone and stone contact with one aggregate rather than using the 4 bins you show. So there's a confirmation there. Here's one question for you guys. Jimmy, if you could switch back to full screen there. What do you do when it stays in the restricted zone during production?
If you remember, from what I've seen, and that's happened with a couple of our mixes, is the number 8 would be in, but we'd still go through the middle. We didn't go above the reference zone, and that's another thing that we got to start. We got to get into the culture of talking about. It's not a restricted zone anymore. This is just a reference zone. We don't want to call it a restricted zone. I think with the changes we've made, it's not a restriction. It's reference now. So we have a couple designs where the number 8 is below the maximum, but then all of a sudden the 3 sieves below it, they come right up or right above it, just barely above it, and it gets flagged out. And you'll see on that template, it was flagged it out in blue. When we first started, it's still approved. It's still, if you're not above, you're going through it or below it. It's still an approved mix design. It's in your master gradation limits. You want to watch it. That's one of those designs. If you see it flagged in blue, make sure you're doing your extra QC testing. Make sure that you have you better bring your A game, because this is where Chuck's talking about that extra 1 or 2% will take you from a 96.0 to a 97.5. I mean, so, you're going to have to really be watching what you're doing those days, and the moistures will come into effect and everything else like that.
Good deal. I got a couple more questions. Let's see. It's also important to understand a mix designer can design. Oops, I don't know what happened there. Let me get out of that. It's important to understand a designer can design in such a matter as there's too much oil. Recently, they found a project where a Superpave B design was 5.5% and had a failing Hamburg, so they adjusted. So, yeah, obviously, you can get crazy on both sides of that. So it is an optimization process, and that's what we're talking about today. And then I had one more comment. I guess this to you, Jimmy. 10% moisture seems high. Would you verify that is correct? I believe you're talking about the sand, but help me out.
That is correct. If we have 10% moisture in our 2 sands, then we will not run. 10%, if we're below 10%, so say we come in at a 9% sand moisture, typically our aggregates are still down around 3%. So, that's not where the moisture is being that's going to hurt you. It's in your sands. And sometimes you got to check your wrap. You got a really fine wrap, you'll retain moisture faster than if you have a coarser wrap too. Even though it's coated with oil, a fine wrap it's got more surface area, so it's going to retain the moisture a little bit longer.
That's exactly right. Also, Jimmy, when you talk about your mix designs, when you started making those changes in your mix design, you said earlier to me, that you've noticed that your bonuses have been more consistent and they've been on the higher side. Once you started making those, you started really getting some really good placement bonuses. You started being able to control your mix. So that's
like earlier when I was talking about when the original mix, when we started and did some test strips and some trial batches, we were struggling to get 92 in place density. once we dropped it down to 35, coarsened it up some, then those 92s started creeping up to 93s, mid 93s. And then once we got it locked in where we liked it and got everything optimized, I mean, we're consistently 94 in place density in the field now. Easy to get. Matter of fact, we have to be careful because we'll fight with over compaction. And we've seen some cores that have come back 96, 97. We got to, remind the 1Bs, hey, make sure you're cutting your reference cores. And now we got them their own scales in the field where they can cut their core and run their core out there on the job site. They'll get their quick number and then send it to the lab to verify their number. So we're kind of got a 2 verification process. And how many times have we seen a dense graded mix where you fight over compaction? It's always been under compaction for the 25 years I've been doing this.
Yes, sir. Hey, there's a great point there, and Jimmy's fading out again. I got to figure that one out. Let's see. Main thing is remembering the team. Check with the field and see how it's behaving in the field when it's being rolled. Yep, that's just what Jimmy talked about. Okay. Let's see. There seems to be a repeating theme that gradation is important. Let's see. So the bigger question is, what are we doing to hold our aggregate suppliers to a high and stricter standard when we, the producer, can only control so much? When you hear that 1 or 1.2% change in the sieve can be the difference between a 96 and a 97.5, it only seemed to be reason that the ag suppliers need to start having significant skin in the game. And I've got 2 more questions once you guys answer this one.
Okay, so the design I just showed you, I'm not going to name producers or anything, but I could just say it is a big name producer who makes a DF blend. So we do see that fluctuation. We see the same fluctuation that I would probably say 30 or 40% other producers in the state see because they rail all across the state. So yes, it can be a problem. This is where running stockpile gradations weekly, tracking all that, watching what's coming in, and then don't just put that mix right up underneath the top end. Push it down further, push it away from that 37. If we're talking about type C, 37 is max, get down to that 31, 32. That way, if you hit if you're at 32 and you hit a fine pocket, it's only going to jump up 34, 35. If it's jumping up 34, 35 on the coarse side through a Superpave press, you'll still be within that plus or minus 1%. You won't be within that plus or minus 0.3%, but you're not going to be a remove and replace. If you're riding on the top end and you hit one of those fine pockets and you're at a 96.2, you hit a fine pocket and your sample comes in at a 40, yeah, you're gonna go outside. You're gonna be at 97.5 real quick. So it's not just getting it right underneath that line and being in, barely in. You want to push it down the maximum you can and balance it out to where you have that wiggle room that's in your JMF already built in.
Good deal. And I got one for Ryan here. What if the district does not allow to pass through the reference zone by plan notes? Will that increase sensitivity?
Will it increase sensitivity?
Or why would it be a plan note?
Yeah, I guess that's my first question is why do we have a plan note saying do not design, I guess, through the reference zone? I guess my thoughts are is that, guys, whenever we put this specification together, the whole idea was to follow it, right? And so will designing through the reference zone cause more sensitivity? Jimmy, you might be able to elaborate on that better, if you will. But I do think that, the whole idea behind using our specification was because we made so many changes that we should probably follow it, right? And so I'd like to follow up after this and know which district. I'd like to see that general note, I guess, if you will.
Okay, so let's see. District. If you wouldn't mind sending a note then to Ryan, and I'm not going to mention who it is because I don't want to get anybody in trouble.
That's fine. Yeah, that's fine.
Just send a note to Ryan so he can follow up. Let's see. I got another comment here. 100% agree, Jimmy. Once it's optimized, the energy needed to compact is much less. Here's one more question. What if the district requires 100% sake aggregates, does not allow recycled materials, neither field sand? How can you design without having sensitivity?
We need to go talk to that district.
Yeah, that's
because
right.
like Ryan just said, the whole point of rewriting the spec and making the changes is so everybody follows the spec as is and not put all these general notes in there. And that's something that we see. That's a training process that TxDOT has to work with, because it's the same thing with our balanced mix design. We're playing with it, we're pulling all the data, and when we release that out there, it's being released for no general notes. It works the way it is. So, if y'all can send that name to Ryan also, that's going to be something that we have to play around with.
Jimmy, your level 2 committee can also look into that with Ryan, with Ryan and Travis. So get the district's name over to Ryan or to me or to Jimmy, whoever, and through your level 2 committee, because that's both TxDOT and industry. And we can definitely address that, because I've heard that before. And again, with the sensitivity to gradation, if you're buying rock on the outside, I know that you're buying what you're buying, you're getting what you're getting. But if you start running those control charts, I'm telling you, I'm a firm believer. Jimmy made me a firm believer at Ramey. When we ran those control charts, you could start seeing when you start having something either creep up on you or creep down, and you can start making JMF changes before you get caught, blindsided. The control charts are so, and when you graph those control charts, it is such a good tool to utilize, guys. I can't stress it enough. Control charts are so good to use, especially with this being around that restrictive zone and being at that number 8 sieve.
Yeah, thanks, Chuck. I just want to weigh in here. We just got a couple minutes left. We burned through an hour, and I think we could probably do another hour. Got one more comment here, and then if anybody has any other questions, go ahead and type them in now so we can get them in here. One last thing, thanks for letting me have some input. I have seen some technicians not getting enough sample. They are getting the same amount of samples they sampled for a dense grade for a Texas gyratory instead of enough material for a Superpave gyratory, resulting in molds not represented to actual mix to 93 to 94% density. Just like the Superpave gyratory compactor not liking fine mixes, they need to be representative of the mix, and the only way to do this is to sample enough mix for the lab. Now, man, we could spend an hour talking about sampling, representative sampling, random sampling, and by God, getting enough sample. That ought to be a minimum, and it's right in there. It tells you how much sample you need. But, man, if you're not getting enough sample, that's something that can be fixed pretty easily with a shovel and a bucket. So you guys got comments?
Well, I know Ryan and I, we talk a lot. I mean, we only live a mile away from each other. I'm the one that honks and everything when I drive by, and he's like, "Who's that?" But if anyone needs help, Ryan has already told me that he is willing to travel across the state or get on a webinar, depending on how the COVID stuff has gone. And I will offer up the exact same. I will come up there and help y'all too. As being a member of TXAPA and being part of that team, I want to make sure that contractors are protected and that we're giving TxDOT what they want. I mean, I guarantee we could probably get Chuck on board where all three of us will go around the state if we have to, and we'll come and it'll be confidential, and we'll help you with these designs and push them where they need to be. And if it's something that we can't figure out, trust me, on our level 2 committee, we got some very intelligent people. If it's something that we can't figure out, we know who to ask or who to call to figure out what can we do or what additional tests do we need to check to figure out why this is not working.
Good deal. Ryan, your closing comments, Ryan.
Absolutely, Jim. I'm just going to follow up with what Jimmy just said. We're here to help. Okay, we are here to help. Please reach out to us if you're having some issues trying to get these designs to pass for whatever reason. We're here to help. So please reach out.
And Chuck.
Yeah. The only thing I have really is that if anybody needs an example of control charts, give me a call, send me an email. I'll get you some examples. I'll get you some Excel spreadsheets. I'm a firm believer, and any help I can do on that end, just let me know. And like I said, I have all the Excel spreadsheets. Just send them my way, and I'll get them to you.
Good deal. Hey, thank you guys. Hey, we are right at the top of the hour. We've 59 minutes, and by the time I get done thanking everybody, we'll be out. So I want to do that. I want to thank Ryan Barborak with TxDOT. I want to thank Jimmy Whited with Austin Materials. Big thanks to Chuck Fuller, awesome guy working for TXAPA as a consultant. We're glad you joined in today. We had almost 70 people at one point paying attention. Had some great feedback on the questions and stuff. Good interaction. It indicates to me that the optimization idea is something that we need to continue to work on. And as Jimmy said, as Ryan said, as Chuck said, and as I'll say, if you guys need some help, please reach out. If you're struggling with something, reach out. And there's times to fight and there's times to work together. And nobody wants to see bad mixes go on the road. It just doesn't do anybody any good. So, our goal is to help you guys put good mixes out, get good solid mixes. I've used the term for years is I want you guys to be making bulletproof mixes. Mixes that can take a little bit of a beating and keep on going. That means a little bit of variation in the plant, and they can also take a little bit of variation out in the field when we're laying it. So if we got something that's so technical that if the wind blows a different direction, you're going to be out of spec, that's not the kind of mixes we need, because that's not going to give us the performance that we're all looking for. So, Ryan wants the performance. He's willing to pay for it. The industry's willing to step behind it and get this thing knocked out of the park. You guys got to do your job and do the research and search for the materials and look for multi-bin operations, and then we'll just kind of go from there. So big thanks to everybody. Thank you again. This will be recorded. This is being recorded, and we'll get it up on the internet just as soon as you can. If you have any questions, feel free to give me or Chuck a call at TXAPA, Ryan at TxDOT, and Jimmy Whited at Austin Materials. So thank you so much for joining today. We appreciate you dialing in, and God bless, and be safe out there.